Hey everybody, this is Mr. Terry, and today I'm going to teach you a lesson asynchronously over tectonic plates. Here you have an overview of the major tectonic plates that are on Earth. Each different color represents a different tectonic plate, and grayed out slightly in the background, if you pay real close attention, you can actually see the different continents. So for starters, this is North America. Here's Florida, here's the coast of Texas, here's Mexico, and that would put us little Red Oak ISD peoples right about there, I'd say. Here's South America, Africa, Europe, here's Asia, Australia, and Antarctica. Okay, so tectonic plates were first kind of, the idea came to this man, Alfred Wegener. He's German. They pronounce their V's with a W. And he studied on it and basically developed this theory that the continents were once joined together in a supercontinent called Pangaea. His idea stated that the continents had drifted apart over time due to their present-day spot, because what he had noticed is that they kind of fit together like a puzzle piece. He called it this. He called it Pangaea. And one thing that he noticed is that obviously the continents do kind of eerily, very similarly fit together, almost like a puzzle board. But what he also noticed is that through the study of fossil records, is that he was finding fossils of animals that were long extinct, hundreds of millions of years ago. He was finding the same animal being alive in places like North America as it was in Africa. He was finding fossil records in India being the same as fossil records in Australia. Well, if you look at a modern day map, none of these continents are touching. And to this day, we don't find an African lion anywhere in North America. But he realized that long ago, when all these animals were alive, these places had to still be touching, or at least really close together, because he was finding the same species living in different continents. So they had to have been part of one landmass at one point. So what do you think caused the continents to drift apart? Well, if you've been paying attention, we have discussed this a little bit in class. And it took a while for Mr. Alfred Wegener to develop this theory. He didn't do this part by himself. This idea came from many people who worked in the field of geology. Basically, what we're talking about here is plate movement. The surface of the Earth fits together like little puzzle pieces, and it's kind of floating over a really thick layer of magma in the asthenosphere. And as each plate moves, they can move in different ways, which causes the Earth to change in different ways. So the first type of plate movement is called divergent plates. This is when plates move away from each other. And divergent plates are plates that separate and move apart. Divergent plates cause the formation of new land. So when you think of diverging, think of things moving away. Some examples of divergent plates are the Mid-Atlantic Ridge. That runs through the ocean, but in this part of the Mid-Atlantic Ridge, you can actually see it on land. You can walk through where the plates are moving away from each other. So there's one plate, and there's another plate. If you were to walk through here, you might not even know what you were seeing, but you're actually looking at geology in the making right here. And every year, these two pieces of the plates move away from each other about 2 centimeters at a time. That doesn't seem like a lot, but if you give it 100 million years, that's a big deal. The thought is that I think the thought is one day this will fill up with water and become an ocean, possibly. But I can't exactly remember correctly if that's the current idea on this one. But here's a spot where you can walk through the ridges. Volcanoes and hot springs in Iceland are also a result of diverging plates. As the plates diverge, It removes land and allows magma to reach the surface, which will heat up pools of water. And it also allows magma from the center of the earth to build up and form volcanoes. Another example is the Great Rift Valley in Africa. This is also a result of divergent boundaries, where you just see the plates again moving away from each other. Okay, so another type of plate movement is called convergent boundaries, and this is how mountains are formed. You think of two plates coming together, and neither one of them wanting to budge. They're both really stubborn. They both say, "Oh, no, I'm going to do it. I'm going to do it. No, I'm going to do it." And instead of one going under the other one, as in subduction, which you've learned about a little bit, they actually kind of build on each other. And that's how mountains form. Convergent plates are plates that come together and they basically collide. Convergent plates cause the formation of mountains, such as the tallest mountain on Earth, which is Mount Everest, which we'll talk about in just a second. So when you think of convergent plates, think mountain building. The Himalayas are the result of convergent plates. And we'll talk about those two plates in just a second. Actually, if I go back through if I go to the beginning, you can see here are the Himalayas right here. So it's a result of the Australian plate and the Eurasian plate, that are the Indo-Australian and the Eurasian plate coming together. Well, neither one is wanting to budge, and so they're building and they're just launching the Himalayas way, way, way up. Let's get back to my little spot there. And that's basically what's building Mount Everest right now. Mount Everest gets 2 centimeters taller every year, I think. Mount Everest will get taller as the Eurasian plate and the Indian plate continue to converge. It gets 2.4 inches taller every year, not centimeters. And here's another look at where the two plates are kind of converging and forming those mountains. And here's another GIF of how that's taking place. You can get a really good look at the way that the plates behave. Obviously, it doesn't happen this quickly. This is in millions of years, so this stuff takes a long, 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 long time. But that's the thing about geology. If you give it enough time, you can see great changes taking place. I like this GIF. All right. So moving on, the next one we're going to learn about is subducting plates. And subducting plates is when one plate goes under another one. Subducting plates cause the formation of volcanoes, and they also cause the formation of trenches. One famous trench that you might know about is the Mariana Trench, which is the deepest part of the ocean in the world that we know of so far. We think there might be some other deep places, but right now, Challenger Deep and the Mariana Trench are the deepest places that we know of. But as one plate subducts, and it takes this old material down with it, it gets superheated down here. Lots of pressure fills up a magma chamber, and then eventually that magma chamber can't take any more pressure, and a volcano erupts. So when you think of subducting, think one going above the other one and the other going down. The Andes Mountains in South America are also a result of the Nazca Plate, which is the oceanic plate, subducting under the South American plate. This is the kind of plate movement that creates volcanoes. And one thing we'll be talking about for sure is the Ring of Fire. This western part of South America is a part of the Ring of Fire. The Ring of Fire is a very geologically active area where there are many, many, many earthquakes and volcanoes, and it almost forms a ring around about half of the entire Earth. Yes, the Ring of Fire! Sorry, I had to do that. All right, what is the Ring of Fire? Well, it is exactly what it says it is. It is a long chain that forms almost a ring around half the Earth. And it's all geologically active areas, many, many, many volcanoes Even here in the United States, we have parts of us that are considered to be in the Ring of Fire. South America, Mexico, up into Alaska, up into Asia, East Asia, Southeast Asia, and into, I forget this part, Oceania. Oceania is what it is. You learn about that in 6th grade social studies at the end of the year. But very geologically active area, so people who live in these places have to be very careful because there's constant eruptions going off, taking place. Here's a look at the Andes Mountains and some of their volcanoes. And also through subduction, this is how trenches are formed, how I mentioned. The Mariana Trench is the deepest part of the ocean, and it's made from subducting plates. Here's a picture of a very specialized submarine making it to the bottom of the Mariana Trench for the first time. I think that trip by these submarines to get down that far takes 6 to 8 hours. It's kind of ridiculous because it has to go very, very slowly. The pressure of the water down here is so intense. It's like the pressure of an elephant balancing on top of a nail. And imagine all that pressure of that one nail. Well, it's like that everywhere on anything that lives down here. But there is life. There is oceanic life that lives down there. There's fish, and there's worms, and there's crabs, and there's all kinds of stuff living down here. It's just not exactly a safe place for people. And to give you an idea of how deep the Mariana Trench is, this is Mount St. Helens, or this is Mount Everest. Mount Everest could fit inside of the Mariana Trench, and there would still be about 6,000 feet of water above it. This is the Burj Khalifa compared to the Challenger Deep, which is in the Mariana Trench. This is where the Titanic sank at about 12,000 feet, so it's less than half the distance to the Mariana Trench. It's pretty deep. It's pretty deep. And this is a look at just some of the weird, wonderful, amazing, spooky, terrifying life that lives down there in the Mariana Trench. There's a goblin shark, frilled shark, anglerfish that lures in fish with this little light on its head. And I think this is a Dumbo squid. And this is just what we know of. We don't even know what else is down there that we haven't found. One more that I'm going to talk to you about is the transform boundary. Transforming plates slide against each other. So instead of going up or subducting or moving away, these actually are just kind of moving alongside one another. This is typically the cause of earthquakes. A famous area where earthquakes are very common is the San Andreas Fault in California. It is a transform boundary. One plate is moving alongside another one. And, I went backwards. And this is what a transform boundary earthquake can do to a set of railroad tracks. It'll literally twist them and bend them like, I don't even know, like a paper clip. So it's a pretty powerful force. And that's the end, bruh. Those are the 4 types of plate movement. Thank you for listening. I hope you enjoyed. Have a great day. Bye, y'all.